Hi everyone, welcome to part 2 of Pre-Calculus Lesson 3.5, complex numbers. So we're reviewing a bunch of different things about complex numbers, and just as a reminder, let's do this quick simplify question. Remember, we use an I when we're trying to do the square root of a negative, because I is equal to the square root of -1. So this is equal to 1I. And when you're trying to do the square root of a negative, remember, it's imaginary. This negative sign becomes an I, then you can just do the square root of 16, and the square root of 16 is 4. Okay? Now, for the square root of -3, this is I times the square root of 3. Now, these are all what we call the principal square roots. They're the positive results. Technically, when they write the square root for us, we can assume that it's positive. If they don't write the square root for us, we can't assume that. We could write a plus or minus sign in front of all of these, and you should do that every time that you're the one introducing the square root. So if you're the one introducing the square root, put the plus or minus sign. If they had a negative sign in front, I would just write a negative here. If they had a positive sign, I could just write a positive. Technically, I probably wouldn't mark it wrong if you did plus or minus sign every time, just in case, unless there was a minus sign there. Then it would be wrong. Okay, so that's just a quick reminder. Now, in this example, they want us to divide complex numbers. So when you're dividing complex numbers, you're multiplying both the top and the bottom of the fraction by the complex conjugate of the denominator. And just a reminder, just like a conjugate radical expression, a complex conjugate just changes the sign in between the real part and the imaginary part. That's what we do. So for this one, I'm going to multiply both the numerator and denominator. Let me just move that. Yeah, I know that extra example is up there, but that's okay. So I'm going to multiply by 1 plus 2i over 1 plus 2i. So I took this denominator, I changed the sign, and I'm multiplying everything in the top and everything in the bottom by that. Now, the beauty of this is that this denominator is a difference of 2 squares now. And you can follow the special pattern for that. 1 squared is 1, and I write a minus sign, and then square this thing. 2 squared is 4i squared. So that is the denominator multiplied out. You square the first, square the second, write a minus sign in between. Now for the numerator, you actually have to multiply that. 3 times I, 3 times 2i, 5i times 1, and 5i times 2i. Now I should combine my like terms. This is 11i. Okay, so those are combined. And anywhere I see an I squared, I'm going to cross it out and change the sign directly in front. So this is a minus 10 there. And this I squared gets crossed out, and I change the sign right here. So I have 3 minus 10 is -7, and then plus 11i in the numerator. And in the denominator, 1 plus 4 is 5. Okay, so this is acceptable as a way to write this. Another thing that you could do is you can write it as -7/5 plus 11/5 I. And all I did is I just separated it into 2 separate fractions, both with a denominator of 5. And that does help you with reducing. If this could reduce, you could then reduce it. And if this could reduce, you could also reduce that. Okay, so it's a good way to write it because you can see how to reduce. So that is my final answer. Let me show you another example. This one's kind of special because, well, notice there's no 2 terms in here. So what sign do I change? Well, all I do is I just change the sign on this 4i, and it becomes -4i and -4i. And then I'll just multiply that through. In the denominator, 4 times -4 is -16, and I times I is I squared. In the numerator, I'm just going to multiply this -4i in. -4 times 7 is -28i, and -4 times 3 is -12i, and I times I is I squared. Cross out the I squareds, change the sign in front. Okay, and you get -28 over 16i plus 12 over 16. Now this is written backwards. The I term should come last, And both of these can reduce. So I'm going to reduce this by 4 to get 3/4. And 28 over 16 can also reduce by 4 to get 7 over 4i. And that is my final answer. Okay, so you have one to try it. This is part of your classwork. Do 5i divided by 2 minus 4i. Pause the video, do that, and then press play to see how to do this example over here. Okay, so for this example, I highly recommend simplifying all of these square roots first. The square root of 12, you should factor it, get your prime factors, do your square root prison story, find the pairs, cross one out, and the other one escapes. And anything without a pair stays in the square root. Now, simplify the square root of -3 to get I times the square root of 3. Now, these are, although the square roots are like terms, this I makes it not like. So you can't combine these. Sorry. If you got all excited because, you were like, they're both the square root of 3, I can just subtract that. You really can't, because the I messes everything up. And the square root of -4 is 2i. So now I'm just going to multiply this out. 2 times the square root of 3 times 3 is 6 times the square root of 3. 2 times the square root of 3 times 2i is positive 4i square root 3. Negative I square root 3 times 3 is negative 3i square root 3. And negative I square root 3 times positive 2 is negative 2i squared square root 3. Notice the I squared can cross out and change the sign. Now I just need to combine like terms. So the 6 square root 3 plus 2 square root 3 is 8 square root 3. 4i square root 3 minus 3i square root 3 is just positive I square root 3. That is my answer. Now we have one more type of example. Here it is. Sometimes when you're dealing with the quadratic formula, you need i's. So it says solve the equation using the quadratic formula. We're going to have imaginary numbers pop up here. Now, just a reminder, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I just need to identify my numbers. A is 1, b is 0, and c is 9. Now, yes, the fastest and easiest thing to do would be to add 9 and then do a square root, but it said specifically to use the quadratic formula. So here it goes, negative b plus or minus the square root of b squared, 0 squared is 0, by the way, minus 4 times a times c, all over 2a. Now I'll multiply all of this out. The zeros are just going to disappear. So it's plus or minus the square root. This comes out to negative 36 over 2 times 1. The square root of negative 36 is 6, and 6 over 2 is positive or negative 3, which we would have got before, except they said to use the quadratic formula. So that's it. Now over here, I'm going to do the same thing. A is 1, B is 4, and C is 5. So again, quadratic formula, negative b plus or minus the square root of b squared. 4 squared is 16, minus 4 times 1 times 5, all over 2a. I will multiply this out and combine like terms. So it's negative 4 plus or minus 16 minus 20 is the square root of negative 4 here, and over 2 times 2. The square root of negative 4 is 2i. And like I did before, this 2 can divide the first term and this term. So I divide it up into 2 fractions, and then I can easily reduce. Negative 4 over 2 is negative 2, and plus or minus this divided, you get 1. Notice this is a pair of complex conjugates. This is negative 2 plus I and negative 2 minus I. They are complex conjugates. And that is the result using the quadratic formula. So that's it for this lesson. Don't forget to do your homework and make sure you ask me if you have any questions.